6232. The conditions most favorable to wave formation over mountainous areas are a layer of A. Unstable air at mountaintop altitude and a wind of at least 15 to 25 knots blowing across the ridge. B. Stable air at mountaintop altitude and a wind of at least 15 to 25 knots blowing across the ridge. C. Moist, unstable air at mountaintop altitude and a wind of less than 5 knots blowing across the ridge. The correct answer is B. The conditions most favorable to wave formation over mountainous areas are stable air at mountaintop altitude and a wind of at least 15 to 25 knots blowing across the ridge. Wave formation over mountainous areas is a phenomenon that occurs when stable atmospheric conditions interact with the airflow passing over the mountains. This creates standing waves of air that can be utilized by glider pilots for soaring, which states that wave formation requires stable air at mountaintop altitude and a wind of at least 15 to 25 knots blowing across the ridge, accurately describes the conditions most favorable for wave formation. Stable air at mountaintop altitude refers to an atmospheric layer where the temperature decreases with height at a relatively high rate, creating a stable vertical profile. This stability prevents the air from freely mixing and leads to the formation of distinct layers. In combination with stable air, a wind speed of at least 15 to 25 knots blowing across the ridge is necessary for wave formation. This wind flow interacts with the mountains, causing the air to rise on the windward side and descend on the lee side. As the air descends, it creates an area of lower pressure above the mountain, while on the lee side, an area of higher pressure is formed. These pressure differences, combined with the stable atmospheric conditions, generate standing waves of air. These standing waves provide glider pilots with areas of lift, allowing them to climb to higher altitudes and potentially achieve long-distance flights. 6233. When soaring in the vicinity of mountain ranges, the greatest potential danger from vertical and rotor-type currents will usually be encountered on the A. Leeward side when flying with the wind. B. Leeward side when flying into the wind. C. Windward side when flying into the wind. The correct answer is B. When soaring in the vicinity of mountain ranges, the greatest potential danger from vertical and rotor-type currents will usually be encountered on the leeward side when flying into the wind. Mountain ranges can significantly affect the airflow patterns and create hazardous conditions for glider pilots. Understanding the potential dangers associated with vertical and rotor-type currents is crucial for safe soaring. The leeward side when flying into the wind poses the greatest potential danger from these currents. When wind encounters a mountain range, it is forced to ascend on the windward side, leading to an area of rising air known as the windward thermal. However, once the air passes over the summit and descends on the leeward side, it creates turbulent and unstable airflow. Flying into the wind on the leeward side exposes glider pilots to the risk of encountering vertical and rotor-type currents. Rotor currents refer to the turbulent, swirling air masses that form downstream of the mountain range. These currents can cause severe turbulence, downdrafts, and unpredictable changes in wind direction and speed. The combination of descending air and rotor-type currents on the leeward side can create dangerous flying conditions, making it the area with the greatest potential danger for glider pilots. 6235. One of the most dangerous features of mountain waves is the turbulent areas in and A. Below rotor clouds. B. Above rotor clouds. C. Below lenticular clouds. The correct answer is A. Among the various hazards associated with mountain waves, one of the most perilous features is the presence of turbulent areas within and below rotor clouds. Rotor clouds are formed when the strong winds encounter obstructions like mountains or ridges, causing the air to flow in a turbulent manner. These turbulent regions within and beneath rotor clouds can be particularly treacherous for aircraft. When flying through these turbulent areas, aircraft may experience severe turbulence, abrupt changes in airspeed and altitude, and unpredictable variations in wind direction. These conditions can pose significant challenges to pilots, potentially leading to loss of control, structural damage to the aircraft, or even accidents. It is crucial for pilots to exercise extreme caution when encountering rotor clouds and the associated turbulent areas. Understanding the dynamics of mountain waves and their effects on aircraft is essential for safe navigation through mountainous regions. Proper weather briefings, monitoring of meteorological reports, and consultation with air traffic control can help pilots make informed decisions and mitigate the risks associated with flying in mountain wave conditions. 6241. Under what condition can enough lift be found for soaring under stable weather conditions? A. Over steep escarpments or cliffs. B. In mountain waves that form on the upwind side of the mountains. C. On the upwind side of hills or ridges with moderate winds present. The correct answer is C. In stable weather conditions, when seeking lift for soaring, one favorable condition is to fly on the upwind side of hills or ridges where moderate winds are present. This configuration creates a phenomenon known as ridge lift. Ridge lift occurs as the prevailing wind encounters the slope of a hill or ridge. As the wind encounters the upward slope, it is forced to rise, resulting in an increase in air pressure on the windward side. This upward movement of air generates lift along the slope, creating an opportunity for gliders and other soaring aircraft to gain altitude. The presence of moderate winds is important for ridge lift to occur. If the wind is too weak, it may not generate enough upward force to sustain the required lift. Conversely, if the wind is too strong, it can create turbulent conditions that may be challenging for safe soaring. When flying on the upwind side of hills or ridges with moderate winds, pilots can strategically position their aircraft to take advantage of the ridge lift. By maintaining a constant angle relative to the ridge, pilots can maximize their time in the lift zone and gain altitude or maintain a level flight. It's important to note that soaring in ridge lift requires skill and experience, as pilots must continuously assess the wind direction, maintain proper positioning relative to the ridge, and be prepared for changes in wind conditions. Safety precautions and adherence to regulations are essential when engaging in soaring activities. 6249. Consider the following statements regarding an Aviation Routine Weather Report, METAR. 1. A vertical visibility entry does not constitute a ceiling. 2. Fog, FG, can be reported only if the visibility is less than 5/8 mile. 3. The ceiling layer will be designated by a C. 4. Mist, BR, can be reported only if the visibility is 5/8 mile up to 6 miles. 5. Temperatures reported below zero will be prefixed with a dash. 6. There is no provision to report partial obscurations. Select the true statements. A. 2, 4, and 6. B. 2, 3, and 5. C. 1, 2, 5, and 6. The correct answer is A. A vertical visibility entry does not constitute a ceiling. This statement is true. In an Aviation Routine Weather Report, METAR, a vertical visibility entry refers to the visibility upward from the surface caused by vertical obscuring phenomena, such as fog or low clouds. It provides information about the vertical extent of the obscuration, but does not necessarily indicate the presence of a ceiling. A ceiling is typically determined based on the lowest layer of clouds that covers a significant portion of the sky. Fog, FG, can be reported only if the visibility is less than 5/8 mile. This statement is true. In METAR reports, the code FG is used to indicate fog. It is reported when the visibility is less than 5/8 statute mile, or 1,000 meters. Visibility is an important factor in determining the presence and severity of fog. The ceiling layer will be designated by a C. This statement is false. In METAR reports, the designation for the ceiling layer is not specifically indicated by a C. Instead, the ceiling is represented by the abbreviation CIG, ceiling, followed by the height of the ceiling above ground level in hundreds of feet. For example, a ceiling at 2,500 feet AGL would be reported as CIG 025. Mist, BR, can be reported only if the visibility is 5/8 mile up to 6 miles. This statement is true. The code BR in METAR reports represents mist. It is reported when the visibility is between 5/8 statute mile and 6 statute miles. Mist refers to the presence of small water droplets suspended in the air, which can reduce visibility, but to a lesser extent than fog. Temperatures reported below zero will be prefixed with a dash. This statement is true. In METAR reports, temperatures below 0 degrees Celsius, 0 degrees Celsius, are prefixed with a minus sign, dash. For example, a temperature of -5 degrees Celsius would be reported as -05 degrees C. This convention helps differentiate between positive and negative temperatures in the observation. There is no provision to report partial obscurations. This statement is true. METAR reports do not specifically include provisions for reporting partial obscurations. Partial obscurations refer to conditions where only a portion of the sky or visibility is obscured by clouds, fog, or other atmospheric phenomena. METAR reports primarily focus on reporting significant weather conditions, visibility, and cloud cover, but not partial obscurations. In summary, the true statements regarding an aviation routine weather report, METAR, are 2, 4, and 6.